72 hours. I'm even counting down to the hours. 72 hours and 72 hours. No, I lie. 5 more hours. 77 hours. No, 76 hours and 57 minutes. I'm counting. So you can imagine, because we close on the Friday. So immediately after school on Friday, I'm gonna have my phone in my hand and I'm gonna re-download TikTok. Okay, I will stop talking about TikTok. Hello, everybody. I'm so glad to see everybody here. I know that we're working with a little bit less people today. So that's okay. We're just going to be doing a little bit of work to introduce a bit of maths that you'll be seeing next year, I'm going to assume, because we're talking about inequalities. I just want to check with you guys. Does somebody just want to pop a message in the chat for me and let me know what you guys have been doing with Teacher Cat? What did you guys do last week, Wednesday? Who can tell me? What did we do? Anybody remember? It was a while back, I'll tell you. So it's okay if we don't remember. No, were we still doing exam revision or were we done? Well, I was still doing exam revision with my grade 10, so I'm not sure what you guys are doing. But that's okay. We're going to be introducing inequalities today. And that's a grade 10 topic, but it's quite easy and it's a nice way to segue into grade 10 work. So give me a thumbs up, guys. Are we ready? Shall we look at what we're going to do today? Yes. Awesome. Amazing, amazing. Okay, let's get into it. So we're going to learn about inequalities. Now, I'm going to quickly scroll over. Let me flip my screen so I can write on it. I'm going to scroll over to the side a little bit. Let's make that bigger. Excellent. Okay, there we go. All right. So if I said to you guys that x is equal to 5, we all understand that what that means. I'm not saying anything large or anything crazy. We've all seen x is equal to 5 before. We've solved for questions where x is equal to 5, right? But now, let's say, for instance, I say to you guys that x is less than 5. And I know that this is less than because the crocodile mouth opens towards 5, which means 5 is the bigger number. 5 is the bigger number. Now, when I say to you guys that x is less than 5, can you guys give me an example of a number that is less than 5? Who can give me an example? Anyone got an example for me? 4, good. 4 will be one of them. Good. 2, 3, I'll venture. Let's keep going down. 0. Minus 20,000. I like that one. Negative 20,000. That's a number smaller than 5, right? And so when we talk about inequalities, we know that the word equalities would be something like x is equal to 5. But when we say inequalities, we're looking at things that could either be 5 or less than 5 or greater than 5. So we're looking for a range of numbers. So when we say we're looking at an inequality, we're looking at a range of numbers. It's many numbers, right? But let me show you guys a little bit more what I'm talking about. If I said to you guys x is equal to 5, and I gave you guys a number line, let me do this. 0, 1, 2, 3, 4, 5. Let's extend it a little bit, 6. Let me go this way as well. -2. -3, -4. And I say to you guys, x is equal to 5. What I'm going to do is I'm going to go to the point where 5 is, and I'm going to put a dot there. And so even if I don't have the equation that says x is equal to 5, I can tell by looking at this that x is equal to 5 because the number line is sitting there and the dot is sitting right above 5. This means x is equal to 5. Yes? Thumbs up. Does that make sense? Everyone with me here? It's an easy-ish concept. It's easy. All right. But now, if I say to you that x is less than 5, if x is less than 5, then definitely 5 is not included. But like we said, 4 will be included, 3 and 2 and 1 and 0, -1, -2, -3, -4, and everything going in that direction. But technically, guys, we are lying. It's not just these numbers. Let's think about it realistically. If x just needs to be less than 5, wouldn't 4,9 also mean that that's a number less than 5? Yes, 4,9 is a number less than 5. I'll do you one better. 4,99. 4,99. That's a number less than 5, right? Or here's another one. 4,999. Right? Shall I do another one, or do you guys kind of get the idea? I could also say 4,9999. Okay. Or, as a matter of fact, all the numbers from 5, right before 5, not at 5, right before 5. So every number that side of 5, all the numbers that we could put dots in here, because 3,54, 3,55, 3,001, 3,22, all of these numbers in between here are also less than 5. It's just that they are numbers with a comma, right? Thumbs up. Does everybody understand that? Yes? All of these numbers, everything in between there. Now, instead of me having to draw ... what I can do is draw a line. A solid line. I can draw a solid line to show that all the numbers in that direction are less than 5, except 5. So because I know that 5 is not included in this, I'm going to do this. I'm not going to draw a dot. I'm going to draw a circle. Ooh, I don't know what that is. Okay, I'm going to draw a circle. And I'm going to leave the circle open at 5 because I want to make sure that everything right before 5 and everything that way of 5 is included. Okay. All right. Shall we look at a couple of examples as to what ma'am is talking about in this case? Yes? Let's look at some examples. I want us to look at A, we're going to solve for X and for B. And now what I want you guys to do, after you've solved for X, because we're actually just solving a linear equation. Once we've solved for the linear equation, I want you guys to give me 3 examples of numbers. In this case, the numbers will be less than whatever that is. And in B, we're looking for numbers that are greater than or equal to, and we'll talk about the greater than or equal to in just a second. But I also want you guys to give me 3 examples of numbers that are going to be greater than or equal to the answer. Okay, I just want to make sure everybody understands what we're doing. Thumbs up. Does everybody understand what we're doing here? Yes? Amazing. Because when we solve for inequalities, we'll solve them the exact same way we would solve an equation. It's just that we won't get one answer. We will get many, many answers. Okay. 2 minutes, guys. This isn't going to take us long. It's not going to take us long. It's really hot today. I'm sweating. You can pop an emoji on the screen when you're ready, guys. Andile's ready. Awesome. I'll give you guys 30 more seconds and then we'll chat. All right, peeps, shall we have a look at the answers? Okay, now the answers aren't going to be as nice as we hoped, but I want to see, guys, pop your examples in the chat. I want to see how creative we get with these. Okay, let's start with A. I know my answer for A. I'm going to go 3x plus 4 is less than 5. I'm going to take my 4, move it over to the other side, and this is going to become 5 minus 4. So I will have 3x is less than 5 minus 4 will give me 1. And then I'll divide both sides by 3. Divide by 3, divide by 3. So x needs to be less than 1 over 3, which is actually 0.3333333 recurring again and again and again. Okay, anybody got examples for me? Which numbers are less than a third? I'm going to give you guys one. My first example. Example 1, a quarter. A quarter is less than a third. Anyone else got one? Just think of any numbers that are less than, let me do this. X is 0.333 recurring. Anyone got an answer? Or I can rewrite a quarter as 0.25. I know that's less than 0.3. Anyone else got an example? Nobody? Anybody? Remember, it just needs to be, that number just needs to be less than 3. The number just needs to be less than 3. And negative numbers would also work here. Okay, I'm getting radio silence. That's a little bit worrying. But okay, let's say for instance, maybe 0.2. Good, 0.2 is 1. And a third example, let's think of a negative number, because if it's 0.3, anything on the other side of 0 will also be a good one. Let's just pick a random number. -7. -7 is definitely less than 0.33333 recurring. Okay, let's look at B. Let's have a look at B. Okay, if I'm solving for B, I'm going to take x minus a half is less than or equal to 3. And I'm going to take the negative a half over to that side, and it's going to become plus. So x is going to be less than or equal to 3 plus a half, which is the same as 3.5. We'll just call it x is less or greater than or equal to 3.5. Now, I want you guys to note that this part over here, which we call the crocodile mouth, opens towards x, which means x is the bigger number. We want the numbers that we want to be bigger than 3.5. Okay, I can already think of one number that's bigger than 3.5. I know that 4 is bigger than 3.5. Anybody got any other example? Anything bigger than 3.5? 6. Good. Nice one, Leachilwe. 6 is also bigger than 3.5. So our second example is 6. Anybody got a third example for us? You can think of the most outrageous number. Good. There's a nice one. 8. 4,5. Good. I like that one. There's a fourth example, 4,5. All right. So it just needs to be a number bigger. But we know that all the numbers from 3.5 going that way are included. Okay. All right. I'm going to give you guys a chance to solve for C and for D. But here's what we're going to do. Okay. Instead of looking for examples of numbers bigger than that, we are going to put those numbers on a number line. So here's what we're going to do. Just going to make some space here. Okay. And I just want to show you guys a quick difference in the questions that we're about to get. Okay. Now, if I say to you guys that x is greater than 2, okay, I want you guys to note that because x is greater than 2, 2 is not included. So we're going to draw a line, and we're going to go to the point where 2 is, and we're going to draw an open dot, because we know that 2 is not included. Everything greater than 2 is included. Okay. But now, if I say to you guys that x is greater than, and if I add a little line at the bottom like that, that line means greater than. This means or equal to. It's greater than or equal. Now, if it's greater than or equal, that means x can also equal 2. That means I must include 2. So I can't draw an open dot because 2 is included. I'm going to close my dot to show that 2 is also included. Everybody understanding what ma'am is saying here? Yes? Thumbs up? Are we all good? Okay, Giselle's good, Leachilu is good, excellent. All right, so again, if I say to you guys, if we find that the answer is x is less than -1, then no worries, Lorianne, great for you to join us. Okay, if I find that x is less than -1, I'm going to draw a number line, and I'm going to draw a line for -1. Now, I'm going to ask you guys, am I going to draw an open, which means an open dot like that, or am I going to draw a closed dot like that? Which one is it going to be? Good, Leachilu gave it away. Good. Okay, we're going to draw an open dot. How do we know that it's an open dot? Because it's not including -1. It doesn't include -1. Right, so if I then say x is less than or equal to -1, then I know that I need to draw a closed dot. I would have to draw that kind of dot. Can we do that? Can we solve for C and D and draw a number line just like this? Yes? Are we able to? Thumbs up. Can I give you guys some time? Okay, excellent. Again, okay, I'll give you guys a little bit more time. I'm going to give you guys 4 minutes because first you have to solve and then you need to draw. A dot for me. Okay, Lorianne, don't stress. Okay, here's what I want you to do. Do you know how to solve for equations, Lorianne? I hope I'm saying your name correctly and I'm not. Yes? Are we able to solve, like if I said to you, 2x plus 1 equals 7. Are you able to solve for that? And I say solve for x. Will you be able to do that? Yes? Great. Okay. Now, here's what's going to happen. Instead of putting an equal sign there, I'm just going to put a greater than sign there. Nothing changes. We're going to solve it the exact same way we would solve a normal equation. It's just that instead of writing an equal sign, you're going to write that symbol there. Does that make sense? Yes, easy enough. Simple, simple things. Quick math. Okay, 4 minutes. I'll give you guys 4 minutes to do that for me. We are answering question C and we're answering question D. Okay, and then we're going to take a pause because there's something I need to show you guys. Okay. Remember to pop an emoji on the screen when you're ready. Lorianne, a bit lost. Have you managed to solve for the two at least? Yes, have you managed to solve for the equations? That's the perfect part, or the inequalities rather than we call them. Okay, my darling, that's fine. I'm more than happy to help, but I'll help in about a minute and we'll chat. Okay. I'm just going to write them down so that we don't get lost. Okay, so C to open bracket 6x minus 6 is less than 0. Okay, I'm going to go to D. 5x plus 4 less than or equal to 3x minus 1. Okay, 10 more seconds and then I'm going to look at the answers. All right, let's look at the answers really quickly. Okay, I'm just going to remind you guys that in mathematics, brackets mean multiply. So what we're actually doing is we're multiplying the brackets by the 2. Okay, so I'm going to go 2 times x, and I'm going to go 2 times negative 6. So I'm going to go 2 times x is 2x, 2 times negative 6 is negative 12, and all of that is greater than 0. I now need to solve for x, so I'm going to take negative 12 over to the other side, and it's going to become positive 12. So I now have 2x is greater than positive 12. I want to solve for x, so I need to get rid of that 2. So I'm going to divide both sides by 2. And x needs to be greater than 6. All right, thumbs up. Did we get to the answer that x is greater than 6? Yes? Awesome. Excellent. Now, let's go look at our number line. Ooh, I'm going to need to erase some of this because I need space. Okay, so if I'm drawing my number line, and again, because mathematicians, we're very lazy, we're not going to make like one of those fancy number lines. No, you're just going to grab a ruler and draw a straight line and draw another line like this, and you're going to put a 6, just like that. Now, tell me, closed dot or open dot? Yes. Awesome. It's open. And how do we know that it's open? Because x only needs to be greater than 6. It needs to be greater. 6 is not included. 6 is not included. So we're going to put an open dot. Well done, Lerilwe. Lovely work. Okay, everybody else, are you seeing what ma'am is doing? Are we okay with this idea? Yes, thumbs up. Are we all okay here? Awesome, because it's that simple, guys. Really, it's that simple. Okay. Is it acceptable if I say it is positive? Yes, you can. If you said that it's positive 6, is that what you mean, Andile? That you wrote x equal, or x is greater than positive 6. Is that what you mean?
Excuse me, ma'am.
Do you mean, when you say, is it acceptable if I say it is positive? Do you mean x is greater than positive 6, like that? Oh, sorry. Yes, Lorianne, you can unmute again, my darling. I'm so sorry. I thought.
Sorry.
No worry.
Can you just explain C again, please?
Okay, sure. Okay, I don't want you to mute, my darling. I want you to stay with me. Do you mind?
Okay.
Okay, excellent. Okay, I just want to check, Lorianne. Are you okay with the fact that brackets in maths mean multiply? Yes?
Mm-hmm.
Okay, good. So I need to multiply the whole of x minus 6 by 2. So I'm first going to take 2 and multiply it with x. And then I'm going to take 2 and I'm going to multiply it with negative 6. You okay with that?
Mm-hmm.
Good. All right. So what is 2 times x?
2.
2 times x. So I need to take 2 and multiply it by x. It's just 2x. Yes? I don't need to put the times there. Okay, so 2 times x will give me 2x. And now for the next one, I've got 2 times negative 6. What is 2 times negative 6? Or rather, let me do it this way. What is
negative 12?
It is negative 12. Good. Like, what is positive 2 times negative 12? I know that the positive and the negative will give me a negative, and 2 times 6 will give me 12. And all of this part isn't going to change because that's not part of the bracket. We're just going to add that onto the inequality. Okay, so that's going to be 2x minus 12 is greater than 0. Now remember, I'm still making sure that I get x on its own. So my next step is going to be to take negative 12 over to the other side. Now, if I had an equal sign over here, and I took negative 12 over to the other side, what would happen to that negative? It would become
positive.
Good. So nothing changes. Just because I've got a greater than sign, it's just going to go over and become positive 12. So I'll get 2x is greater than positive 12.
12.
Okay, good. Now, I don't want 2x. I want just 2x, but I know that 2x means 2 times x. How do I get rid of the 2?
You bring it over.
How do we bring it over? Remember, it's not minused, it's multiplied. So when we took this one over, we added it to the other side. So if this is multiplied, what is the opposite of multiply?
Adding.
Think again.
No,
What?
no. Subtract. Is it
Mhm.
subtract?
Opposite of plus would be
Uh,
minus, right? What's the opposite of times?
divide.
Divide. Good. So if I'm taking this one over to the other side, I'm going to have to divide by 2. Does that make sense?
Mm-hmm.
Okay, good. So now I've taken the 2 over to the other side. It's gone. Now I've got x is greater than, what's 12 divided by 2?
12 divided by 2 is 6.
6. Lovely. 6. And that's how ma'am gets this answer of 6 over there.
Oh, now I understand. Thank you.
Excellent, my darling. Keep asking questions if you need. All right.
Okay.
Awesome. 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 Okay, cool. Let's look at D. Okay, again, I always need to do bod mass, guys. So I'm always going to start with the brackets. Let's start with the brackets on this side. Okay, now because I'm doing the brackets on this side, nothing needs to happen on that side. I'm going to leave that side exactly the way that it is. It's not part of the equation just yet. Okay, so I'm going to leave this part exactly as it is. 5x plus 4 would be less than or equal to, and then because I've got brackets, distribute. 3 times x will give me 3x, and 3 times -1 will give me -3. Thank you, Leah. Amazing. Okay, good. Now, the thing with these questions is we always want x on its own on one of the sides. So that means this 3x over here is on the wrong side. I now need to take that 3x over to the other side. But because it's a positive 3x on this side, when it goes over to the other side, it becomes a -3x. And the positive 4 is also on the wrong side. So I need to take it over to the other side, which means when it goes over to that side, it's going to become a -4. Let's rewrite this. 5x didn't move, so 5x stays. But what comes over and joins it? 3x, which is now -3x. And that is less than or equal to. Now, the 4, the positive 4 also needs to move over to that side. And because it's positive 4, when it goes to the other side, it becomes -4. The -3 was already there. So we're just going to put it down and then add -4 to the side. Okay, and then we just do quick math. Simple, add like terms. 5x minus 3x will give me 2x. And that is less than or equal to -3 minus 4 will give me -7. Beautiful. Oh, Leahila, I feel like you could teach this class. I could take a break and Leahila will just show you guys what to do. You've got this. You've got this. All right. How did we get the 3? Oh, Andile, remember? 3 times x is 3x. And then 3 times -1 is -3, right? So now I've got 3x and -3. Is that okay, Andile? Are you understanding that part? You okay with that? Cool. All right, last step, because I don't want 2x. I want x. I'm going to
Excuse me.
divide. Yes, my darling.
So when you said 5x plus 4 now,
Yes.
is greater than 3. So like when you like using the formula, do you take away the brackets because you're timesing it?
Yes. So once I've multiplied, the brackets must go away because they've done their
Okay.
job. Okay. All right, my darling. Okay, good. So I need the 2 to go away. How do I make the 2 go away? I divide by it. Okay, so divide by 2. And I must also, whatever I do on the left-hand side, I need to do on the right-hand side as well. So this will also cancel out. Right, so x will then be less than or equal to, now this is just going to give us a fraction. It's just going to give us -7/2 because 2 doesn't divide into 7 without leaving a remainder. So we're just going to leave it as -7/2. But now we need to put this on a number line. So I'm going to do that. And then I'm just going to do that. Just like that. And I'm going to go -7/2. Let's talk about what goes up here. Open dot or closed dot? I'm going to remind you guys. Good, Leachila. I'm going to remind you guys that this says less than or equal to. So if x can be equal to -7/2, then I must include it. So I must put a closed dot. Okay, I just want to take stock quickly before we continue. Give me a thumbs up if you understand everything ma'am has just gone through. Thumbs down if you'd like to do another question, and I have to explain again because there's something we really need to go through really quickly. Okay, excellent. I'm glad. And keep asking questions, guys. Keep asking questions. All right. I feel like E and F are going to be quite the tricky one. Okay, let's extend this idea. We're going to extend this idea. I'm going to write that some a little bit differently. Now, we're solving, right? We are solving. If I give you guys x plus 2 is greater than 3, can you guys solve for x for me? Tell me, what is x greater than? What is x going to be greater than? Good, good. Amazing. All right. I know that I want x on its own, so that +2 must go over and become -2. So I'm going to end up with x is greater than 3 minus 2. And that gives us that x is greater than 1. Okay. Now, on a number line, we would just draw a line like this. And we would go there and put a 1 there. And I know because it's just greater than that I need to put an open dot. Okay. Now, I'm going to ask again. What kind of numbers are greater than 1? Any example? Numbers greater than 1. I'll give you an example. 1, 1 is bigger than 1. Good. 2 is bigger than 1. Anything else? 4 is greater than 1. Oh, I don't know what happened there. Okay, 2 and 4 and 3, 3 and 5, 5 and 6, 09 and 1, 004. All of these numbers are greater than 1, right? And we know that all of these numbers represent x, right? And because x is every number greater than 1, we're just going to do this. We're going to say all the numbers in that direction going on forever. And what do we call it when numbers go on forever and ever and ever and ever and ever? What do we call that in mathematics? It goes to what? Anybody know what it's called? I'll give you the symbol. Yes, that's it. That's it. Moline. Hello, Moline. Amazing. Good. It's called infinity. So this arrow, when we draw that arrow, we're saying that x is every number greater than 1 all the way up till infinity. Okay. Are we all happy with that? Excellent. Okay, cool. Now, let's look at a different one. Let's look at a different example. I'm just going to take that away because technically I only need the number line. Now I'm going to say x minus 7 is less than or equal to 1. All right, give me an answer. What is x less than? Eight. Good. Very simple. Right. I want x on its own, so I'm going to take -7 over to that side, and it's going to become +7. So I'll get x is greater than or equal to 1 plus 7. So x is less than or equal to 8. Now I'm going to go to my number line, draw a line like that, put an 8 there, and then I'm going to put a dot. What kind of dot? Open or closed? Open or closed? Anybody? Yes, it has to be closed because our question says here, or our answer here says, x is less than or equal to 8. So I must close my dot. All right, give me examples of numbers that are less than 8. Numbers less than 8. I'm going to start us off. 7,9 is less than 8. Nice. 0,333. 4. Good. Okay. So we know that it's all the numbers in that direction. Good. 2,0 is another one. It's all the numbers in this direction. Now, who can tell me What do we call it when the numbers go in this direction all the way? Where is it headed? To what number? What number is it headed to? Anybody know? Yes, it is negative, but negative what? Negative what? Negative infinity. Good. So in this direction, we know that x is all the numbers less than 8 all the way up to negative infinity. Okay. All right. Let's do a bit of an experiment really quickly. Now, if I said to you guys that 2 is less than 5. True? Yes? Thumbs up. Is that a true statement? Yes? Awesome. Amazing. It's an easy question. I wasn't trying to trick you guys. I promise. It's a true statement. I'm just going to plug in my charger before my computer dies. Okay. All right. It's not a trick question, I'm telling you guys. Okay, so now let's say I do this. I go 2 minus 1. But now remember, if I do something on the left-hand side, I also need to do the same thing on the right-hand side. So I'm going to minus 1 on this side as well. Okay, so I've now got 2 minus 1, that is 1. And on this side, I've got 5 minus 1, which is 4. And then I'm going to put my symbol in the middle. Is that still a true statement? Yes? Are we okay with that? Yeah, 1 is still less than 4. 4 is the bigger number. So my crocodile mouth opens towards 4. Okay, now I know for a fact that if I plus, I'm going to end up with the same situation, right? If I plus 1, this is just going to become 3, and this is going to become 6. That statement is true. All of it is true. Now let's do this. What happens now if I multiply by negative 1? Now, what I do on the left, I need to do on the right. So I now multiply by negative 1 times negative 1. Now, 2 times negative 1 will give me negative 2. And 5 times negative 1 will give me negative 5. And then I go ahead and I put the symbol in the middle. Ooh, what's wrong with that statement? What is wrong with that statement? That's not true, right? Because if we look on a number line, here's 0, right? That's negative 1, negative 2, negative 3, negative 4, negative 5. Last time I checked, 2 was closer to 0 than negative 5, or negative 2 is closer to 0 than negative 5 is. So this means as soon as I multiply by a negative number, okay, as soon as I multiply by a negative number, what happens to my symbol in the middle? My symbol needs to switch. Okay, thumbs up. Does that make sense? Everyone with me there? Amazing. Okay, let's look at a quick example. Okay. Oh, remember guys, even if I divide, let me not do that. Even if I divide by negative 1, 2 divided by negative 1 will still give me negative 2, and 5 divided by negative 1 will still give me negative 5. So I need to switch my signs. Okay, now, here's your sum. 2x plus 1 is less than or equal to 4x plus 7. Okay. Tell me what my answer is. Okay, remember, anything that doesn't have an x, or anything with an x, must sit on its own side, and anything without an x on the other side. And if anybody's brave enough to unmute and do this question with me, I would love, love, love to hear your voice.
I could try, but like, don't judge. I'll try.
No, absolutely no judgment here. That's my whole job for me to get you. Okay. All right, my darling, where would we start? What do you think we're going to do?
We start by removing the x.
Good. Which number with x? do we want to move? There's two of them.
2x and 4x.
Good. We need both of those on the same side. Do you agree?
Yes, miss.
Good. So which one am I going to move? Sorry, which one am I going to move? Do I want to move 4x over to that side? That makes sense. Yes?
Mm-hmm.
Okay, good. So I'm going to take 4x and I'm going to move it over. But now this side is positive 4x. What's going to happen when I take it to that side? It's going to become?
Negative.
Good. So what needs to move to the other side?
4x.
Okay, 4x is going to move to this side. What needs to move to this side?
2x.
No, my darling. Remember, we want both of them on the same side, right? So if I take 4x over to that side, then 2x and 4x are going to be on the same side. Do you see what I mean? So I've now got 2x, and we said that 4x will come over and become negative 4x, right? Which guy on this side doesn't belong here? Which one doesn't have an x and needs to move?
1.
Good, the +1. Right. So I'm going to take the +1 over to the other side. What's going to happen to it on that side?
It's going to be positive.
Oh, it's positive over here.
Sorry, negative.
It's going to become negative, right? So now I've got 2x minus 4x is greater than or equal to, what do I already have? What number do I already have on the right-hand side?
7.
Yes, we still have the 7. So the 7 is already here. And then what comes over to this side now?
1.
But it's not just 1. It's positive 1. It goes over and it becomes?
Negative 1.
Good. So now we've got 7 minus 1. 7 and negative 1. Okay, let's do some quick math. What is 2x minus 4x?
Negative 2.
Negative 2 what?
Negative 2x.
That's it. Good. Negative 2x. And that will be greater or equal to 7 minus 1.
7 minus 1 is 6.
Good. 6. Good. Now, remember, my darling, I want x all on its own. What do I need to get rid of?
You need to get rid of the 2.
Good. It's
The
not just
negative 2.
Negative 2. Good. And these two are multiplied to each other. And remember, we said the opposite of multiply or the opposite of times is divide, right?
Divide.
Good. So we're going to divide on this side by negative 2. But what I do on the left-hand side, I also need to do?
On the right-hand side.
Good. So I'm also going to divide by negative 2 over here. Okay. Now, I know that anything divided by itself is just going to cancel. Right. So now I've got x on its own. I've got x left. X. What number do I get on this side? 6 divided by negative 2?
Negative 3.
Good. Negative 3. But don't forget, I have just divided by a negative number. I've divided by a negative number. So what needs to happen to my sign in the middle?
It has to change.
Yes, we need to switch the sign. Yes, good. So whereas my sign was facing that way, now my sign needs to face
The other way.
the other way. Good. So there we go. It's equal to, and Lorianne, you did that so beautifully. Just mwah.
Thank you.
Excellent work, madam. Good. Do you want to help me finish off? Shall we finish off? Because we still need to put this on a number line. Don't forget.
Okay.
Okay, good. So for my number line, I'm just going to grab a ruler and draw a straight line, right? And then I'm just going to draw a line like that. What goes here underneath that line there? What do I put here?
Your 4.
Just the
3.
sign. Good. It's not 3, it's?
Negative 3.
Good. Negative 3. Good. Now, above here, I'm going to have to put a dot. What does this part tell me? What kind of dot do I want? Is it going to be an open dot or a closed dot?
And open. Or closed.
It's closed because we are also, this sign over here means equal to. or equal to. So if x can also be equal to -3, then we must also show that it's equal to -3 there, the closed dot. Okay, now if you look at this part over here, do you see how this sign opens up towards -3? Do you see that?
Mm-hmm.
So that means -3 is the bigger number. Can you give me a number smaller than -3?
-1.
Ooh, remember on a number line, this is -2.
-4.
Good, -4 will be smaller, right? So it's all the numbers in this direction. Okay, so my arrow will have to be in that direction. Are we okay with that? It does take a bit of practice, I'll tell you. Okay. Well done, my darling. I love, love, love you for trying. We can always try another one. Yes?
Thank
Feeling
you.
okay? All right, my darling. Well done. Amazing. Excellent work. Okay. Everybody got the idea here? Can I give everybody one more example to try because the lesson is about over? Yes? Let's go for it. Okay. I'm going to make it a bit complicated. Let's make it a little bit more juicy. Okay. I'm going to go 2, open bracket. X minus 4 is less than 3 x plus, let me see, x plus 1. Okay. Don't forget, solve for the inequality and represent it on a number line for me, please. Okay. Go for it. Give you guys a couple minutes. Remember to pop an emoji on the screen when you're ready with the answer. Yarina's already done. Or if you're struggling with the question, pop a message in the chat. I'm happy to help. Oh, just grab some water. Remember, brackets mean multiply.
Miss, do we have to do this problem? Try and do it.
Yes, yes, my darling. Yes, it's for you guys to try.
Okay.
All right, guys, I'm going to ask you guys to pause if you're not done, because we're going to run out of time, and I want us to really get to this answer. Okay, I'm just going to go through it really quickly and see if you've got the right answer here. Okay, first, I know brackets mean multiply, so I'm going to multiply with each of those. 2 times x will give me 2x, and 2 times -4 will give me -8, and that will be less than, and again on this side, brackets, so 3 times x and 3 times 1. 3 times x will give me 3x, and 3 times 1 will give me +3. Okay, now again, anything without anything with an x goes one side, anything without an x, other side. So I know that 3x must come over to this side, and -8 must go over to that side. Make sure everything with an x one side, anything without on the other side. So 2x is already on the right side, so I'm going to keep it here. And joining it on this side will be 3x. But because it's positive 3x, when it comes over, it becomes -3x. And this is less than. 3 is already on this side, so we have 3. And the thing that will join it, -8, will come and join it, but it goes over to that side and it becomes +8, +8. Okay, then we just need to add like terms. 2x minus 3x will give us -1x, and there's a reason why I'm writing -1x instead of -x. You can write -x, that's also correct, is less than 3 plus 8 is +11. Okay, now to get x on its own, I don't want 1x, I want -x. So what's going to happen is I'm going to divide by -1 to get x on its own. And what I do to the left-hand side, I need to do to the right-hand side as well. Also divide by -1. Those two will cancel. I will now have x. 11 divided by -1 will give me -11, but I have now divided by a negative number. So the sign in the middle needs to swap. So that needs to happen. Okay. Oh, sorry. Hi, guys, I'm lying to your faces. There we go. It needs to go that way. Other way around. It needs to switch. Okay. And now on my number line, I'm going to go and draw a line like that. And I'm going to put -11 just there. Good. I didn't even get to that part of the question yet. Okay. Now, because in this part, there isn't an equal to there. There's no equal to sign. I now need to draw an open dot. And because my mouth opens towards x, that means x needs to be the bigger number. We know that bigger numbers bigger than -11, will have to be -9. -5 is bigger than -11, -6, good. So it's all the numbers in that direction. Okay, so we're going to do that. All the way up to +infinity. Okay, we are 2 minutes over the lesson.